All right. It's afternoon right now, so good afternoon, everybody. Oh, who's that? HDMI unplug it. Okay. All right. So today, what we're going to do is I'm going to start chapter 4, which is the time value of money. Let's see, I don't have something here. Back on this screen. All right. So chapter 4, the time value of money. Basically, what we want to talk about is the value of a dollar today versus a value of a dollar in the future, or the value of a future dollar today. Okay, so what we're going to find is it's going to be a function of the amount of time and the interest rate that we're going to be using to either compound or discount. Okay, so when we're moving into the future, we have money that we have today, and we're talking about what that money is going to be worth in the future. We're basically talking about compounding the interest. Okay, and I don't know how truth this is, but there's a saying out there that Einstein once said the most powerful force in the universe was compound interest. And we're going to talk about compound interest and how money grows today. We're also going to talk about how we can end up trying to figure out what kind of money we would have to put aside today to create a certain dollar in the future. Okay, so we're going to talk about present values of future money. We're going to talk about future money of present dollars. Okay, we'll talk about annuities today also. So in chapter 4, and I'm going to click back and forth between my picture and chapter 4 in the text back and forth so we can see things. Well, the other thing is that there's going to be an Excel spreadsheet that we're going to be working with. Now, there's 4 different ways that we can do the various calculations that we're talking about. We can do them by doing all of the various functions that are necessary. We can use the formulas that have been created for us to come up with the numbers. You can use a financial calculator to come up with all of the numbers. And the final way is to use an Excel spreadsheet. I've chosen to do this course based on using the Excel spreadsheet. So you've all been trained in Excel. I don't know if you've used these particular functions that we're going to be talking about, but I'm going to do, as I said, I'm going to do this based on Excel as opposed to, nobody wants to sit and calculate these things out by hand. So really the only other realistic choice is the financial calculator, but I don't have one, although I have the function on my phone to create a financial calculator. I just feel that since we're all on our computers all the time, and we have the computers in the classroom, and I'm doing things teaching from a computer, why not just use Excel? So Excel is what we're going to end up with. Okay, so let me share my screen. So we'll go to chapter 4. So what we're looking at this point is chapter 4. And one of the things the book wants you to do is it wants you to start thinking in terms of timelines. So you've got a line graph there that shows the future and shows the various periods that we're going to be going through. So if you look at this, what we have, there's talking about $100 in current money. So the present value is $100. What's it going to be worth 3 years from now? And also, they're going to give us a 5% assumed rate. Okay, so assuming that we're going to be able to invest this money at 5%, what's it going to be worth in 3 years? Now, you may say to yourself, oh, that seems like it's pretty easy. 5% of $100 is $5. We have 3 periods here, so 5 plus 5 plus 5, 15. So in 3 years, it's going to be worth $115. No, that's what's called simple interest, which means that we just come up with what the interest rate is times the principal. for each year that we're out there. But what's going to happen is if we don't take the money out of this particular investment, then year one, yes, we put our $100 in. If you look at the time chart, we put that $100 in on the time chart timeline where it says 0, and we get our 5% when we get to 1, which is the end of the first period. Okay, so our $100 when we get to point 1 on the line graph, now we have $105. Okay, so when we now move from period 1 to period 2, that $105 is what is going to be getting the interest. Okay, not the 100 that was the original principal. We now have a new principal value, which is the principal plus the prior interest. So now in year 2, it's going to be 5% of $105. Yeah, I know we're talking pennies, but this will end up accruing to be big numbers if you do it long enough. Okay, year between 2 and 3 to get to year 3, we're going to have not the 105, not the 110, but whatever the interest on the $5 here was added into that. We'll look at those numbers specifically in a couple of minutes. All right, so there's your timeline, and understand we start at 0 and nothing really happens until we get to period 1 on our timeline. Okay, that's the first time that we receive the money from our investment. So it's worth $100 until we get to right here where the 1 is. Now it's worth 105. Okay, so keep track of that. All right, so I am going to click on this toolkit here, and it's going to give me the Excel spreadsheet that I want. Okay, it's my Excel is starting up, and I'm going to have it on this screen over here. Just give me a second. All right, and I will share this with you as we go through things also. So what I want to do, okay, let me stop sharing. And now let me share the spreadsheet. Okay, so this is a spreadsheet that our authors give us to work with. And basically, here are the 4 methods of calculating what the future value or the compounded value of our investment is going to be. So looking at this, let's start with number 1. Step by step, we multiply the principal times 1 plus I. Okay, so it's going to be 1.05, right? So that's how you get to the answer for what we're going to have at the end of period 1. So in period 0, we have the original investment of $100. At the end of period 1, we've multiplied that 100 times 1.05, and we get $105. Now let's multiply it again to get to the end of period 2. Now, as I said, it's not going to just be $110. We now have this extra 25 cents that comes from the compounding of the interest. That's the interest on the interest. All right, so it's not 110, it's $110.25. Then we get to period 3 here. We multiply 110.25 times 1.05, and we get $115.76. So what you can see is at the end of year 3, we've picked up an additional 76 cents worth of interest because we are getting interest on our interest. And realistically, here in period 3, interest on our interest plus interest on our interest plus interest. Okay, so this interest here ends up being doubled, if you will. It has the interest factored twice. This one's going to have it 1 time. Okay, so you can do that. There's no problem with doing that. That is a very simple way of coming up with the proper calculation. You could set it up in an Excel spreadsheet. It would be very easy for you to do. Just let Excel do it. You have all the various columns and everything. And that's all fine and dandy until you get some very large numbers, very long periods of time. Then you have a calculation that becomes kind of cumbersome. Okay, so we really don't want to monkey with that too much. But number 2, the formula. So it's going to be present value times in paren 1 plus interest close paren, to the nth power. Okay, so for our 3-year cycle here, it would be 100 times 105 to the third power. And so when you multiply that out, you would actually come up with the right answer, the $115.76. All right, fine and dandy. What about a financial calculator? If you have a financial calculator, feel free to look at the instructions in the book. It's all there. You can easily follow along with the instructions for a financial calculator. I'm not going to teach you how to use a financial calculator. I will teach you how to use the Excel functions that we want to use. Okay, so we've talked about 3 methods: step-by-step method, the overall formula method, you've got the financial calculator method, and this over here is just telling you what button to push on your financial calculator. Now we've got the Excel spreadsheet, okay? So we have different things. Now, the function itself, the future value function, which they'll designate as FV sub n, will be equal to the future value using interest, number of periods, 0 stands for type, and the present value. Okay, so what I'm going to do is I'm going to bring up an Excel spreadsheet that I was using when I was preparing for this particular lecture. So let me give me a second to bring that up. All right, so now I'm going to move this to this page for right now. Okay. Well, that's going to be difficult. Just have to move it back over here. All right. All right, so the book is talking about, on the next page in the book, it talks about the fact that what we're doing is we're calling this compounding, and I've already gone through that for you, so yes, we know all of that. I will now share again. Give me a second to All right, so you're looking at the textbook, page 143, the step-by-step approach. We have that timeline again, starting with 100 at period 0. We go to 105 at the end of period 1, 110, 25 at the end of period 2, and 115.76 at the end of period 3. So we know those are the numbers because we've seen them in the spreadsheet that was already shown to us. And your book is just going through and explaining that extra 25 cents worth of interest is because we are now earning interest on year 1 interest. So $5 times 5% is that 25 cents. Okay. And then, of course, that goes to 76 cents in year 3. All right. So that's the step-by-step approach. I want to move through because they're going to now talk about the formula approach. Okay. So we've talked about the formula. Let's go past this. Now they're going to talk about the financial calculator, which, as I said, I'm not super interested in teaching you how to use financial calculators. But I do want to talk about the Excel, which is the next thing that would be in here. Okay, so this is the spreadsheet, right? So, and of course, they're pointing out that we have the spreadsheet that they have made available to us, the publishers have. All right, so one of the things that they want to do is, what we could do, and I guess what I'm going to do is I'm going to stop sharing this and I'm going to share my spreadsheet. Okay, now you have a spreadsheet that I didn't make it look all pretty or anything, but basically what I've learned is that when you're using Excel, what you want to do is you want to create a place to put your inputs, okay? And so for the future value calculation in Excel, there's certain things that you will find, and you'll find as I move down here that I've added present value and future value. Or when we're looking for future value, obviously future value is not an issue, but later on it becomes for other calculations. But anyhow, what I need to do is I need to, where are the functions? I need to move some things out of the way so I can see. Where did they go? Formulas, here we go. You have to click on formulas. Okay. And then over here, insert function. That's what we want to really be using and worrying about. So I'm going to click on insert function. I have to give us a spot here. Insert function, and it's going to bring up the various financial functions that are available to us. Okay, so what we're looking for right now is future value. So if you look right here, FV is what we want to choose. So I'm going to click future value, and then I'm going to approve it. Now it brings up an input table for us to use to calculate future value. So if all I was worried about was getting an actual number in here, I could actually put my variables right into this input table. Now, one of the things that you'll find will be useful to you is to go through the process that I've done here, where you set up your input table as part of the spreadsheet itself. Okay, so now first thing that I did was I created the spots that I wanted: rate, numbers of period, payment, present value, and type. And these will all become useful later. Then what I did is I went through and I turned this cell into percentage. And all you have to do is you have to right click on that cell and then go through and choose the type of cell you want it to be. So I made it a percentage. So when I put my input in there, I didn't have to type in 0.05. I just typed in a 5, and the spreadsheet already knew that I wanted 5%. So that's why it shows up there as 5%. So, all right, the rate, it's looking for the rate. So notice I have a flashing cursor there. So now what I do is I just click on that cell. Notice it brings it over into the inputs chart here. Next thing I want is number of periods, NPER. So number of periods is 3. So I brought that cell over here. Then the next thing that I need is it's not a payment. Payments are going to be from when we're talking about annuities later. It's going to be the present value. Now, you'll notice that I have the $100, which is the original investment, as a negative number. The way that Excel works with this is if money is going out, it needs to be reflected as a negative number. So me making the investment, it's cash out. So this $100 is cash out of my pocket. So in order for it to work in here, it has to be a negative number. So I'm inputting that as a negative 100. I'll put that as far as present value, and then I'll click that. And then I'm just going to hit OK. Okay, so notice the cell over here that I had asked it to fill with the present, or excuse me, future value, the compounded value of our $100 over 3 years at 5%, it calculated it out for me. Now, the thing is that now I've got a chart here that's going to work no matter what my inputs are. So if I want to say, I wonder what would happen if this was all of a sudden 6%. Well, that would go to $119.10. What if it were 4%? Then it'll be $112.49. See, it automatically will calculate it for you. Now, notice it's doing it over here too, because when I set this up yesterday, when I was trying to get all these functions to work, I set it up to work over here. And I'm just doing it over here for the illustration purposes for the class. Okay, so I'm going to put it back at 5 because that's what we're using for the class purposes right now. So we saw from the books chart that our compounded interest or future value would be $115.76. And yep, Excel calculated that for us. So we're in good shape with that. Okay, so I guess the big lesson to take here is to set yourself up with the inputs that you think you're going to need. Now, in reality, all I really would have needed were these three: rate, NPER, and present value. I didn't need the payment or the type. I'm getting into the habit of doing that when I set up my input charts, because later on it becomes useful because you have those other things. When I set this up originally, I didn't have my calculation ready to roll. Once you set that up, once you hit this function button, anything you do is going to go into the function. So I wanted to have this all set up before I started monkeying with that function button. Okay. All right, let's go back to the book for a minute. Oh, I guess I never shared any of that, did I? Well, I'm going to do it again then. So if I didn't share it, I apologize. I'm going to hit delete over here, get rid of this. And I'm just going to point out, so I'm sure, I think it did share. So I'm just going to do it one more time. So function, future value is what I'm looking for. So you click on FV, hit OK. Here's the input chart. Rates, NPER, and present value are the things I'm going to use. So I'm going to click here. I'm going to click on the cell that has my percentage in it. You notice it's brought over. Number of periods. I click on the chart. Then I click on my cell. That's fine. And then my present value, the negative $100. I click on that cell. It brings the cell notice over here. And then when I hit OK, it does the calculation. So that 115.76 is what we wanted to have happen. Okay. Back to the book. That's what I wanted to do. Okay, so they're talking about the value of doing an input sections in there, and I think it makes a lot of sense to me, because then you have the ability to use this as you move forward. Like I said, if there's going to be a change in the percentage that you're going to be earning, you can just change that number and it will automatically make the change for you. If you're changing the number of periods, changing the amount that you are going to be investing. So once you set this up, you have the ability to make it work for you. All right, continuing on. Step-by-step calculations. And so basically, and what I'm going to do is I'm going to stop with the book and I'm going to go back to the other calculation on this is the spreadsheet that the book gives us to use. Okay, so you can see that what they did was they set up, and they only used the three. I had my input chart having the six, but they had the investment, they have the interest rate, and they had the number of periods. So those are the three that you need. All right, so the book wants you to do that with the input charts too, and I do agree with that. All right, so you can take a look at what the book has to talk about. Please do read the section of the book that talks about how to work with Excel to make these things happen. It's very useful. I think this is a wonderful tool. So we're going to move forward now. There's a discussion in the book, if you will, about the difference between the financial calculator and the spreadsheet. Somehow, one has advantages over the other. I've made the decision that I'm teaching the course based on the Excel spreadsheet. So that's the way we're looking at it. We also have, and I can look at either in the book, I'll share the book with you. They show a a graphical a graph that shows about how things grow if they are if there's compounding involved. And so you see right here, we start with our $100, and this yellow line here is 0%. So we don't have any interest being paid. So it's just a straight line. We keep that $100 forever. It doesn't matter how many years that we go. They also show that the growth rate can be negative because you may end up losing money on your investment for some reason. And if you have a continuing negative growth or loss, that the chart will start approaching zero over time. Realistically, it'll never hit zero because we're talking percentage of reduction. It's just that eventually it'll become very, 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 very small. And so therefore the movement itself will become very small. It will approach zero. It won't become zero. So then if you look at the other lines that are out here, this blue line is 5%. So you see that it's growing. And it, and once again, and it's most easily shown here on the 20% line, which is, I guess, a dark purple or dark blue, that as time goes by, that compounding of the interest changes the the slope of the line. If all we were doing is simple interest, it would be a straight line that goes like this. There's definitely a curve to this line because of the additional interest on interest, the compounding that happens over time. So the longer you leave it in there, that compounding becomes very, very powerful. Okay, so you can see how the slope of the line has changed over a 10-year period. If you want to extend that out for a longer period of time, then the slope of that line is going to become much more pronounced. So that's a graphical representation of what compound interest looks like. The next thing that we have in the book is simple interest versus compound interest. So the big difference is in our $100 over 3 years at 5%, we saw that with compound interest, we ended up with $115.75 or whatever it was. With simple interest, all we're doing is paying interest on the principal. It doesn't matter how many years we leave it in there. We're only going to be getting that interest being applied to the principal. So if we don't have compounding and we have simple interest being given here, we're going to end up with $5 worth of interest every period. So we're not going to get that extra 75 cents. We're going to not, there's no compounding involved. Our graphic line will be a straight line at a slope, but it won't have any curve to it. It won't grow over time. It's just going to be $5 in period 1, $5 in period 2, $5 in period 3. So at the end of 3 periods, it would be $115, not $115.76. Okay, and it becomes a difference. Understand that most of the world wants to deal with compound interest because that's how you're really going to be able to make money on your money. But understand that simple interest does exist out there. Okay, so just be paying attention to what the problem asks or what the document says. Whatever it is you're working with. Interesting little tidbit in the textbook. Benjamin Franklin, when he died, he wanted to leave money to his 2 homes. He was born in Boston, but he spent most of his professional life in Philadelphia. So he left £1,000 to the 2 cities. But he wanted to make sure that the money was going to have the ability to do really great things. So he insisted that £1,000 not be spent for the first 100 years after his death. And so as you can see in the textbook here, he left $1,000, which would have been around $4,500 to Philadelphia and Boston, be invested for 100 years, after which the proceeds to be used for public projects, trade schools, and waterworks, and the rest invested for another 100 years. Depending on interest rates, the strategy could generate quite a bit of money. For example, if half of his bequest, $22.75, remained invested at 5% compound interest for 200 years, the value in 1990 would have been $39.3 million. We're talking about the investment of, what's it say, $2,275 would have grown to over $39 million in that 200-year period. That's the power of compound interest, okay? Ultimately, the best laid plans of mice and men, right? His money was spent long before it was ever allowed to grow to that point. So it never got quite to that level. So sorry, Ben, we cheated you. All right. So now we've looked at how to get a future value. So we're talking about compounding our interest. So we're compounding our investment to come up with what the future number is going to be. So if I had $100 and I knew that I wanted to invest it I didn't need it for 3 years. And I knew I could get a CD that was going to pay me 5% for 3 years. What's it going to be worth 3 years from now? So now we know how to calculate that, okay? You can do it in one of 4 different ways, but we know how to do it. All right, so what if we want to do the opposite thing? What if we need to have a certain amount of money in the future? How much do we need to put aside today to make sure that that money is available when we need it in the future? Okay, so this is the reverse of what we just did. What we're going to be doing is it's called discounting. We're going to be bringing things from the future into the present. And so if amounts got larger as we moved into the future, and we're saying this is the exact opposite, money is going to get smaller as we move back in time. Okay, so $100 3 years from now is going to be worth significantly less than $100 because we would have had the opportunity to invest money. So if you say that the $100 in the future is the same as the $100 today, you're not taking into account the fact that I could have invested that at 5% for 3 years at compound interest and had $115.76. They're not the same thing, okay? So when you're talking about money, understand that money has to be compared in similar time frames, okay? And so this is actually one of the things that you need to be able to do in order to be able to make financial decisions. So let's assume that you have the opportunity to spend money on a machine today. $100,000 to buy a machine today. Okay, what's that going to do for you? Well, it's going to get me $110,000 in additional profits over the next 10 years. Is it worth doing? And the answer I can tell you right now is going to be no, because that extra $10,000 you're going to get over a 10-year period is going to be almost nothing. Okay, so let's look at all of this. All right, present value is what we're talking about today. If a broker offers to sell you a bond that will pay a guaranteed $115.76 in 3 years, should you buy it? If your other alternative is to put your money in a CD at 5% for the 3 years, which is the better investment? Okay, without doing some of the calculations, you don't know. Now, from going through that last calculation where we took that $100 and we put it aside at 5% for 3 years, we know that it's going to be $115.76. So if we want to buy this bond for $115.76, which is going to pay us in 3 years, what should you pay for it today? No more than $100. Because if you pay more than $100, you would have been better off in the CD, because we know the CD paying 5% would get you the $115.76. Now, if they want to sell you this bond at $90, it's a great deal. Go ahead and do it. But you don't know until you go through the calculation. All right, so let's move along in the textbook here. All right, I'm gonna show the share my textbook screen. All right, so discounting a future value to find the present value. And they just talked about the same thing here. If you were going to buy that bond that paid $115.76, you can't pay more than $100 because that's its fair price. And later on, we're going to be actually be calculating values of bonds as to what its actual market value will be. And changes in the interest rate in the economy are going to change the value of a bond. You'll see that when we get to that. The $100 is defined as the present value or PV of 115.76 due in 3 years at a 5% investment or discount rate. So in general, the present value of cash flow due N years in the future is the amount that, if it were on hand today, would grow to equal that future amount. Okay. It's called discounting. It's the reverse of compounding. You want to have a formula? Here's the compounding formula. Here's the discounting formula. So you can do that anytime you like. If you like doing the math, it's right there. So it's going to be present value is going to be equal to future value subscript n for how many periods in the future over 1 plus interest to the nth power, how many periods in the future. Okay, so there's how you do it. I will now move over to I have to stop sharing and share the. This is the worksheet that they give us in the book. All the things we talked about. So now we're talking about present values, which is part of the textbook at 4-3. All right, so now how do we calculate the present value? Well, we still have our 4 methods, right? Now notice they've set up a new table of inputs for us here. So we know the future value is the $115.76. We know that the interest rate is 5%, and we know the number of periods is 3%. So here's your timeline. We know that in the future it's going to be worth $115.76. What's it worth 2 years in the future? What's it worth 1 year in the future? What's it worth today? Okay, so it works backwards exactly. So if it's worth 115.76, we know that at the end of period 2 it was 110.25. At the end of period 1 it was 105. At the beginning it was 100. Here's your formula. We talked about that. It would be 115.76 over 1.05 to the 3rd power. That would give you the $100. The financial calculator, once again, if you want to look at that so that you can figure out the how to use your calculator, go right ahead. I will stay with the spreadsheet. Okay, so spreadsheet function is the PV function, present value. And we're going to be worried about interest, number of periods. The zeros, we'll talk about that later when we talk about annuities, and the future value. Okay, so I'm going to now go to my little worksheet that I was playing with, make this all happen. Okay, so this is, like I said, this is just me playing with the worksheet to make sure that I was comfortable with how this all worked. So now I have, okay. Oh, I'm in the wrong section. That's one. Okay. So present value right here. Rate we know is 5%. Number of periods is 3%. There is no payment because once again, payment deals with annuities, which we'll talk about shortly. Future value we know is the $115.76. Type once again deals with annuities. So what I'm going to do is I'm going to just pick a cell here, and I'm going to go to my function, click it. It's going to bring up present value. So I hit present value, and now it brings up the input chart. I'm hoping you guys can see this. I don't know if this is something on a separate screen, but it looks a lot like what was in the book, where it just gives you 1, 2, 3, 4, 5 different boxes that you can fill in. And the boxes are rate, number of periods, payment, future value, and type. So what we need for this one is rate. So it's going to be the 5% rate. I'm going to use cell B12. Number of periods is asking for a number of periods. I'm going to click over here. That's B13. Payment is not valid for this, but future value is something that we have. So I'm going to use cell B15. I click OK, and you see that it gives me my $100. Okay, gives me the negative $100 because remember that was the negative that we had to put in way back here when we were compounding because that's money out of pocket. This 115 is not a negative number because that's money that we receive in the future. So we would be getting that money. That would be a positive flow. So that means that we would have to pay out this $100 in the past in order for us to get that. So it's going to come back as a negative number. All right, back to the book. We already looked at the so the PV, the present value function in Excel and a financial calculator asks the question, how much must I invest today in order to have available to me a certain amount of money at a specific time in the future? Okay, so that's what we did there. We said, okay, we need to have $115.76 3 years in the future. How much money do I have to put aside today to get that number? Okay, so that's the present value function. We just saw how you do it very easily in Excel. I'll show you the graph that's in your book. So present value of $100 at various interest rates and time periods. So at 5%, it's going to be worth, we know the 100, well, this number of years. Okay, so if we were 3 years out, anyhow, you see that it's a downward slope because we're discounting to come back into current time. The lower the rate, the higher the value. The higher the rate, the lower the value. You see this at 20%, it drops down basically to nothing around year 25. Once again, that's not zero, it's approaching zero, but it's not going to be zero. Self-test, what is discounting? How is it related to compounding? It's the opposite of compounding. It basically takes a future value and brings it to current value, present value. How does the present value of future payment change as the time to receipt is lengthened as the interest rate increases? It's an inverse relationship. The more the interest rate goes up, the smaller the amount. So the lower the interest rate, the higher the amount. Suppose a risk-free bond promised to pay $22.4973 in 3 years. If the going risk-free interest rate is 4%, how much is the bond worth today? All right, so let's go to our little chart here. I'll bring that up. We have it available to us. All right, so we're going to find a finding the present value. So let's see, the question was promises to pay $22.4973. So I'll put that in here at the future value. $22.4973. 3 years. Okay, we have the 3 in there already. And it's 4%, so we'll change that to 4%. All right. The book says it's $2,000. Our Excel calculator said it's $2,000. The book asks another question: how much is a bond worth if it matures in 5 years rather than 3 years? So change the 3 to a 5. That takes the value according to the book to 1849.11. Okay, our calculator makes it 1849.11. If the risk-free interest rate is 6% rather than 4%, how much is the 5-year bond worth today? So change the rate to 6%. And the number of periods is now still 5 years. So So the book says it's 1681.13. Our little calculator says it's 1681.13. So our Excel processes work very well for calculating out the things we need to see. So we see that we can calculate a future value, which is the compounding of an investment at a specific interest rate for a specific period of time. We can calculate out the present value, which is a number, an amount, some point in the future that we now have to bring back X number of periods, and we have to assume what the interest rate that we would be able to get would be. If we have those three numbers, we can find the fourth. Our nifty little calculator will do that for us. Okay. Oh, let's do this last one. It's a little crazy one that they put up for us in the book here. How much would 1 million do 100 years from now be worth today if the discount rate was 7 or 5%? Okay, so $1 million. So future value is going to be 1, 1, 2, 3, 1, 2, 3. That's our $1 million. Discount rate is 5%. And our number of periods is 100. So if you were to take $7,604.49, invested at 5% for 100 years, you would get that $1 million. So what if we were getting 20%? Now the book says it's a penny, it's 0.0121. We rounded here to 2 digits. So basically you invested a penny at 20% for 100 years, you would get $1 million out of that. So that's quite interesting. I want to set that back to where we had it originally. So notice how by using the table here that we were able to do all of those calculations without having to do a lot of thinking. You know, all we had to do was change the numbers in our table, and it worked very well. All right. So how about, we were talking about the fact that we have 4 different things that we can know in these calculations. What if we are missing one of the other things? Okay, so for example, what happens if we don't know the interest rate that we need? Okay, equations 4, 1, 4, 2, 4, 3, find future and present values. Now, what if we have 4 variables, and if we know we have 3 of them, we can calculate the 4th one. So if we know present value, interest, and number of periods, we can solve for future value. Or if we know future value, interest, and number of periods, we can find the present value. Suppose we know the present value, the future value, and the period, the number of periods. Can we find the interest factor? Okay, let me share the book with you. All right, so they're going to give us a formula to use. So interest is going to equal future value at whatever period of time in the future over present value, all to the 1/nth power minus 1. So go ahead and do that if you like. Or here's the calculation that would be required in your financial calculator. Or how about we just use the rate function in Excel? I'm going to stop sharing the textbook. I'm going to bring back my silly little spreadsheet that I created to use. Okay, so finding the rate. The rate function we use, find the rate, you need the number of periods, you need the payment, you need present value, you need future value. So here's what I set up. I'm going to click. So I set it up here. If I know that I have a rate of 5%. Oh, no, wait a minute. I'm looking for rates. I'll get rid of the rate. We don't need that. So if I know that I have a number of periods of 3, if I know that I have a present value of $100, and that's a negative number, remember, I know that I have a future value of $115.76. I'm going to go and click on my insert function, and I'm going to click rate. And rate gives me a input page of number of periods, payment, present value, future value, and type. So number of periods is going to be 3. I also know my present value. Whoops, I did that as the actual number. So I'm going to put B21 there. Present value I know is here, B23, and future value is B24. Put those in my input chart, click OK, and it comes back telling me that 5% is the rate necessary to take $100 to 115.76 in 3 periods. So you now have 5%. All right, back to the book just to check through. Okay, can we do anything else? Well, certainly we can. If we found the rate, can we find the number of periods? That would be another thing that would be useful if we knew how long we had to have something invested. So once again, if I have a future value of 115.76, a present value of $100, how long would I need to keep that invested? I go to my function, insert function, and I come back with do it there, insert function, and I click NPER, number of periods, click OK. It gives me choices of rate, payment, present value, future value, and type. So I'm looking for the numbers of periods. So I have the rate. I'll put that in. I have the present value. I have the present value, so I put that in the present value box. And I have the future value. I put that in the future value box. I click OK, and it comes back. Now I have a rounding issue here, 2.999955736. Obviously, if I change the way this thing presents itself, it would round to 3. So obviously, the number of periods is 3 or something very close to 3. Okay, so I was able to find the future value. I'm able to find the present value of a future number. I'm able to find the rate. I'm able to find the number of periods. What else? That's where we are. Okay. So finding the number of years. Just so that I can say that I did, I'll share the book, page in the book with you. Okay, so this is page 155 in your book. I'm ignoring, of course, the financial calculator. So if we were to use in Excel, we would use the NPER function. And they gave us a different problem here. So it became, sometimes we need to know how long it will take to accumulate a specific sum of money given our beginning funds and the rate we will earn. For example, suppose we have $500,000. All right, so I'm doing number of periods. Present value is a negative $500,000. Interest rate is 4.5. And our future value that we're looking for is $1 million. Okay. Stop sharing the book. I'm going to share my silly little annuity worksheet here. So I had put in the 4.5%. I put in the present value of $500,000. I put in the future value of $100,000. $15.747, and looking back at the book has set 15.7473, so 7.7473. Perfect. So it's good to know that our book and our worksheets are agreeing. So I assume the book is right. I think it is. Going back, I'm going to look at self-test. How long would it take $1,000 to double if it were invested in a bank that pays 6% per year? Okay, so we're going to be looking for the number of periods. Finding rate, number of periods right here. Okay, so we had $1,000, so negative $1,000. How long would it take to double? Our future value is going to be $2,000, and we know our rate is 6%. Number of periods is 11.895. The book rounded it to 11.9 years. So that's fine. The question continues on. How long would it take if the rate were 10%? All we have to do is go back in here, change that to 10%. 7.27. Yep, 7.27 is what the book says. A company's 2013 earnings per share was $2.75, and its growth rate during the period, during the prior 14 years was 16.35% per year. If that growth rate were maintained, how long would it take for earnings per share to double? Okay, so let's just put a number in there. So our current value of earnings per share is 2.75. Future value, what's twice 275 is what, $5? So 5. And our growth rate was 16.35. 3.94. No, they're saying 7.2. Oh yeah, 4.58. What did I do wrong? Oh, 525. It's not 5, it's 525. 550? 550. 4.577. Okay, so yeah, we're right. The simpler math got me. 275 times 2 is not 5. 5.5, John. Okay, so let's keep moving. All right, perpetuities is the next thing that's in the book. Some of the things that we're going to be dealing with are not going to have a due date. So, for example, if you were to buy a share of stock in Microsoft or IBM or whoever it is you want to be dealing with, when is your share of Microsoft due? It's not. It never comes due. It's something that is supposed to live on forever. So it will go on for perpetuity, never ending, right? That's one of the advantages of the corporate form, is that we don't need to worry about it ending on because of somebody's death, or if something happens to the owner, the corporation keeps going. We theoretically create these corporations to go on forever. All right. So what happens? How do you value something that doesn't ever end? See, because what you're actually, remember what the book said in chapter 1. The value of a company is basically the value of all of its future free cash flows. Okay, so when we get to the point as to what is going to be the value of this company, we need to look at year 1 free cash flow, year 2 free cash flow, year 3 free cash flow, year 4, year 5, year 6, year 7, year 8, year 9, year 28, year 37, year 104. But the thing is, we're now learning that money that we get in the future doesn't have the same value as money that we have today. Okay, So we have problems here. We're trying to add together money that doesn't necessarily have the same value. So if we were going to do that, we could, but what we would need to do is we would have to calculate out what the free cash flows would be in that future year. So let's look at the fifth year from now, so year 5. So that we know we have 5 years worth of growth. We know that if we put $1 aside right now, that it would that 5% it would be worth something more at that 5-year point in the future. So whatever money we're looking at in the future is going to be worth less today because we have to discount it to bring it back to present value. So what happens is that stream of income that we're talking about that's moving into the future, as it gets further and further and further into the future, because of the fact that we are squishing it back down to bring it into its value for present value, it becomes worth less and less and less as time goes by. So the next 5 years worth of free cash flows are going to have a value. We can calculate them, but that free cash flow that's out 20 years in the future, by the time we get done discounting it back to today, it's going to exist. It's going to have a number, but it's going to be very small. So small that I don't know that it's actually even material anymore. Okay, so I'm going to put the book up so we can talk about perpetuities and how we calculate perpetuities. All right. Perpetuities. Some types of stocks and bonds pay a fixed amount each period, but don't have an ending date. Because payments are perpetual, this pattern of cash flows is called a perpetuity. You can't apply the step-by-step approach because the cash flows never end. But like I said, you get to a point at some point in the future where the number that you're calculating becomes very minimal. The present value of a perpetuity is the payment over I. This is a very simple formula, and this is what we use for the valuation of a perpetuity. So suppose the payment is $25 each period, and the interest rate is 2.5%. The equation then is going to be, per present value equals the payment over I. So the payment is 25 divided by 0.025. So if you divide by a fraction, but so that $25 payment is going to say that instrument or whatever that investment is has a present value of $1,000. Okay, so we can set that up in our little Excel chart if we want. I didn't bother doing it because it's just such an easy calculation. So what would happen to the present value if interest rates were 3%? So now if they are $25 over the 0.03, which would give us a present value of $833. Because the interest rate went up, the value of our instrument dropped. Okay, it's an inverse relationship. However, if interest rates were to go to 2%, then the present value would go to $1,250. Okay, so when the interest rate change, the present value also changes, but inversely to the change in the rates. Thus, the present value declines if rates rise and will increase if rates fall. Okay. All right, so now let's get a little more complicated. So we've done a lot so far about trying to figure out how to do present values and how to do future values. And we've now calculated the present value of something that doesn't have an end. It has a flow into the future. Let's talk about annuities. Okay, so what is an annuity? An annuity is a stream of money that moves into the future. It is a payment of a specific recurring amount for a particular period of time, not in perpetuity, because if it was perpetuity, we would use that other calculation, which would be payment over interest rate. Okay, annuities have an end. We know how long the annuity is going to last, 5 years, 10 years, whatever. Okay, And we're just going to have to know what our interest rate is going to be, okay? Assets such as bonds provide a finite series of cash inflows over time, and obligations such as auto loans, student loans, and mortgages call for a finite series of payments. If the payments are equal and are made at fixed intervals, we have an annuity. For example, the amount of $100 paid at the end of each of the next 3 years is a 3-year annuity. If payments occur at the end of the period, we have an ordinary annuity called a deferred annuity. There's a different type of an annuity, and that's if the payment is made at the beginning of the period. That's called an annuity due. It's right there in your textbook. And I think they're going to give us, yes, a chart here, a line chart, a time chart, a timeline. Yeah, that's the word, timeline, that shows. So the top timeline is an ordinary annuity. We make our first payment at the end of the first period. So when we start at 0, there's nothing there. We make our first $100 payment at the end of the first period. We make our second payment at the end of the second period. We make our third payment at the end of the third period, okay? An annuity due is the opposite. We make our first payment at period 0, our second payment at period 1, and our third payment at period 2, okay? There's no payment out here at 3. Now, what's going to happen is when we calculate the value of this annuity, the annuity due is going to be worth more. Why? Because it has this additional period to earn interest. This one up here, that whole first period, there's nothing in there to earn interest. So you don't start earning interest until actually the end of the second period. With the annuity due, the money goes in at the very beginning. So at the end of period 1, you're putting the second payment in, but you are also collecting the interest that's being paid on the annuity, okay? All right, so what we're looking for is the future value, the present value, the interest rate built into the contracts, how long it takes to get to a financial goal using the annuity. If we know all of the values, we can even calculate the size of the annuity payment. Keep in mind, annuities must have constant payments, consistent payments at a fixed number of periods, okay? If we have that, then we can play with all of our calculations and come up with values for these streams of income, all right? All right, so let me just make the next page. All right, future value of an ordinary annuity. So I'll just use that out of the book here. So it's an ordinary annuity, which means we don't make the payments till the end of period 1. All right, so we make a payment here at the end of period 1, at the end of period 2, at the end of period 3. So this payment that's made here at the end of period 1, what's it going to be worth at the end of this annuity? Okay. Now we knew from when we did this, we saw this before. When oh, let me get it. I have it. Okay, I'm sharing the spreadsheet that the authors have made available to us. So when we were talking about calculating this money, this payment at the end of the first period where it earns interest was $105. So if we look at that payment on the annuity table, we see that. If it's gotten interest for 2 periods, it's worth $110.25. Now let me go back to the book. So this one here, which is going to end up with 1, 2 periods where it's going to earn interest, is that $110.25. This payment at the end of year 2 is going to have 1 period to earn interest, and that's going to have no compounding, it's going to be 105. The third payment, which is made at the end of the third period, if it's being valued at the end of the third period, doesn't have any interest growth, so it's going to be that $100, okay? So if we add those three together, 100, 105, and 110.25, we're going to have $315.25, okay? So now, we've got a formula. You can do the formula if you want. You can play with the financial calculator if you want, or you can do the financial spreadsheet that I want to do. Okay, so this is going to be for the future value function. Well, wait a minute, Kamalchak, don't we need a future value of an annuity? No, the future value function will allow us to calculate an annuity. So let's go and find it. All right, so I'm now sharing my my simple little spreadsheet that I did to prove to myself that these things actually worked. And now I'm down here where I have it labeled as calculating the future value of an ordinary annuity. Okay, so now if we had that $100 payment, which is what the illustration in the book was, we're making a $100 payment. It's an ordinary annuity, so the payment is going to be made at the end of period 1, the end of period 2, the end of period 3. If we just use the future value function, and we have these three factors, we know the rate, we know the number of periods, and we know the payment that we're making every year. So let me get a spot there. I'm going to click on future value in my choices here. Now rate it's asking for, so I'm going to use B38. Number of periods, I'm going to use B39. And now I have payment. It's the first time we're using payment because we're making that annuity payment. And so the payment is going to be cell B40. And then I just hit OK. $315.25 is what our calculation on the spreadsheet comes to. And that's exactly what the book said it should be, $315.25. So now what happened here is that we did two things. We're compounding interest, but we're compounding interest on multiple numbers as we move forward in time, okay? So that first payment had two periods where the interest was earned. So you get that $5 for the first period, and then you get the compounding, so you get another $5.25 for the second period. The next payment was made at the end of period 2, so it's going to earn interest between period 2 and 3. So it's only going to have 1 year's worth of interest. It's not going to compound. It's going to be that additional 5. The third payment is made on the valuation date in the future, so that's going to be valued at year 3 money. Okay. So what we have here is the calculation of the growth of these things that are moving forward in time, okay? So we have 3 payments moving forward in time, each one of the payments getting its own version of compound interest, okay? So this is a complicated thing. You can easily, you can do it. You can do it with the transactional thing. It's just that you're going to be following through with all of the various payments. So let's say you had 120 payments, you'd have to calculate through each of those payments. That's 10 years. Is it possible to put money aside every year for 10 years? Sure. What's it going to be worth? You can do all those little calculations if you like, or you can just come to Excel and plug it in my little table here. So what I say, 120 periods. Let's say that it's a $100 payment, and it's 5%. And at the end of 10 years, those $100 payments would be worth $695,000. So, interesting. Second 3. All right. So we've calculated now the future value of an annuity. What happens if we want to go backwards in time? We want to find out what kind of an annuity payment would we be required to pay now if we wanted to build up a certain amount in the future? Well, wait a minute, Kamalchuk, didn't we calculate out present values of future numbers before? Yes, we did. But what we were looking at was one lump sum payment that was going to be moving forward in time. Now what we're talking about is annual specific amounts paid on a regular basis for a regular number of period of time to get to a number that we want to get to in the future. Go back to the book for a minute. All right. So this is the book discussion about what we just did. All right. Oh, sorry. We can't get to what I was talking about yet because we still need to talk about an annuity due. Okay, before we start talking about the present value of an annuity, let's talk about an annuity due. Now remember, an annuity due was we made the payment in period 0, not at the end of period 1. We did it at the beginning of period 1, basically the end of period 0. So what that means is that our first payment will have 3 periods to compound interest. Our second payment will have 2 periods to earn compound interest. And even our third payment will have 1 period to earn interest. It won't be compounded because it's just 1 period, but we have the ability to do that. All right, so let me go back to the book. Yes, I forgot we needed to do the future value of an annuity due. So there's not that much to really worry about here. In Excel, we still use the function, but we must indicate we have an annuity due. All right, so I'm going to go back to my spreadsheet. We're going to show you the difference here. An annuity due. So the same thing, 5% interest rate, 3 periods, and $100 payments for each period. Difference is this is made at period 0, 1, and 2. This one's made at period 1, 2, and 3. All right. The difference is down here where I have had type. We've had that type. You guys, I'm sure, have been wondering, why do we have that cell there? It's labeled type. What's that mean? Type is where we decide whether it's an ordinary annuity or whether it's annuity due. If you put a 0 or leave it blank, Excel will assume that it's an ordinary annuity. If you want it to be an annuity due, you have to choose type 1. All right. So now I'm going to go to the, first I'm going to do is set myself up a little box over here. I'm going to hit my insert function. I'm going to do future value. I get my input boxes here. Rate is still going to be B47 at 5%. Number of periods is going to be B48 at 3 periods. Payment is going to be B49 at $100 negative. And then all I'm going to do is go into the very bottom box here, and I'm going to hit type, which is going to be 1, which is going to be, I guess, B52. If I click enter, it calculates for me $331.01, the exact number that the book says we should have calculated. So look at the difference there. They're both on the page there in front of you. The irregular ordinary annuity, the future value of those $100 payments is $315.25. When we make it an annuity due, where we start payments 1 period early, we end up with $331 as opposed to $315. And that's that additional compounding. So we end up with an extra like $15 because we made the payment 1 payment early, or 1 period early. So the annuity Remember, it's payment at the end of period 1, end of period 2, end of period 3. Annuity due at the beginning of period 1. So it's made at period 0, at the end of 1, and at the end of 2. So everything's moved up by 1 period. Okay. Now we can start talking about present values of annuities. So when we know what number we want in the future, we know that we want to be able to have some number in the future that we need to get to. How much do I have to put aside every year or whatever in order to get to that number? Now, this is where I left off. I said, hey, you're saying, Gamalchek, didn't we already calculate this when we calculated the present value? We knew that we wanted X number of dollars in the future, and we knew we were able to calculate what the present value of that number was. So we had $115.76 in the future, means we would have to put $100 aside today to get to that $115 number, right, Gamalchek? Yes. But what if you didn't want to do a lump sum? What if you wanted to do it in 3 annual installments to get to that number? How do you calculate that? Just take the $100 and divide by 3. No, it's not going to work. No. So what we have to do is we have to be able to calculate the present value of an annuity. And oh, wait a minute, present value of an ordinary annuity and present value of an annuity due. Got it? All right, so I believe we're looking at the book here. I'm sharing the book. So as you can see, and this is once again, if you guys are going through this on your computers, you can click on that that input thing so you can get the publisher's spreadsheet up that has all this information in it. So they've set it up with payment amount of $100, interest rate of 5%, number of periods is 3. So we knew we had, if we made these payments and we were to put that into the future value, we'd end up finding that our future value, but anyhow, doing it backwards, we have that $100 payment, bring it back. Anyhow, this would come back 2 periods. This would come back 1 period. Now this would come back 3 periods. This come back 2 periods. This would come back 1 period. So this is an ordinary annuity. Okay, so going backwards, we have to actually take into account that we're going to lose interest here also. So these numbers are all going to end up getting discounted. So this $100 payment in period 1, we're going to lose 1 period's worth of discounting. So that's worth $95. Period 2's payment is going to discount back. We're going to lose 2 periods of discounting. So it's going to be $90.70. Period 3 is going to have 3 periods worth of discounting. It's really only worth $86. So if we add all of those together, we're going to come up with $272.32 as being the present value of that $100 annuity. Okay. Let's go to the spreadsheet and see how it works. All right, so now present value of an ordinary annuity. So they're telling us, I just set it up same way they did. 5% is the return. Number of periods is still 3. And the payments that we're going to be making, once again, that negative $100. So if I want to do this, what I'm going to have to do is I'm going to have to go to insert function. And now I'm looking for present value, choose PV. It'll give me my input boxes of rate. So once again, I'm going to use the cells B57. The number of periods, I'm going to use B58. And the payments, I'm going to use B59. And since this is an ordinary annuity, I don't have anything in type. So if I had a 0 there, that'd be fine. If I leave it blank, that's fine. I hit OK in my input box. and it calculates it out for me at $272.32. Okay, so that's how that works. Now let's talk about the present value of an annuity due. Okay, because each payment for an annuity due occurs one period earlier, the payments will all be discounted for one less period. Therefore, the present value of an annuity due is going to be greater than the present value of an ordinary annuity. So once again, you can go to the spreadsheet that they provided and see how that works. I liked going to my own, and I'm going to suggest to you guys that you do that. Set up your spreadsheets, uh, go through the function choosing, set up your chart of inputs here, and then watch how it calculates it for you. It's actually very nice, very simple. I think Excel is a wonderful program with a wonderful tool. Get to know it. So anyhow, if we go through, we of course can go through the 4 different methods to come up with the value of our annuity due. In Excel, this is all it says about the Excel in the chapter. It says in Excel, we again use the present value PV function, but now we must include that we have an annuity due. So that means we're going to put in type. We're going to have a 1 where type is. So I believe I'm sharing my spreadsheet. I'm going to go out and go back in just to make sure. Okay, so present value of an annuity due. So once again, it's an annuity for 3 periods. Our payments are going to be $100 for each of the 3 payments that we make. The discount rate is going to be 5%. And notice that we do have over here where it says type, we have that 1. Okay, so now if we set up, click our function insert, and we look at present value, just click present value, bring it through. We're going to have our input boxes there. Rate is going to be B66. Number of periods, B67. Payment is going to be B68. And then we're going to skip future value. Let's put in type. Our type is going to be 1, B71. I click OK. $285.94. Our book says it should have been $285.94. So we're good. All of our tools work. Okay, spend some time. I'm going to ask you to spend some time. Okay, this is where I'm going to end today's lecture. We're at what, an hour and a half ish in. What I want you to do is I want you to create your own spreadsheet. Understand that I didn't do anything fancy here. I didn't set up any fancy headings. I didn't do anything other than created my tables and then gave myself a box where I was able to run my calculation. I guess I should have put some sort of a label here. So this one should be future value of $100, 3 years at 5%. So I could have done something like that. But understand, just go through, run those calculations. Use the ones that are in the book so that you can see that you actually did it right. Because if you come up with the answer that they came up with in the book, obviously you did it right. If you don't come up with the answer that they had in the book, then you made a mistake somewhere. Go back through and figure out where your mistake lies. I'm going to leave you guys on your honor. I'm hoping that you spend another hour going through creating your own spreadsheet using these function buttons that are in Excel. Hopefully you were able to follow along. I don't know if that extra table, when it came up on my spreadsheet, if it came up on what you guys can see on this recording. So you may have to go through the steps just to bring up the fact that you have that that input box. Let me just see something here. Let me see. If I stop sharing, I go back to my table here and I click on it, then I hit function. And if then I try to share, does that come up? Back to me, share, does that come up? Yeah, it didn't seem to come up on the spreadsheet that's being shared. It does seem like it's coming up on what I see. So I think you've been going through that and seeing that the whole time. Stop sharing and reshare. So yeah, it looks like you've been able to see that. So if you've been able to see that, that's great. You've seen it all together. If you weren't able to see that particular input box come up, please spend some time going through the process. Set yourself up a spreadsheet that gives you the ability to do each of these. You know, how many were there? There were, let's see, here. See, 1, 2, 3, 4, 5, 6, 7, 8. We did 8 calculations, 8 different functions. We did future value of a dollar with compounding interest. We did present value of, so discounted back of a present value. We did finding the rate when we knew the other things for present value or future value. We went through finding the number of periods. We went through calculating the future value of an ordinary annuity. We calculated the future value of an annuity due. We've calculated the present value of an ordinary annuity, and we calculated the present value of an annuity due. In addition to that, although it's not on the spreadsheet here, we did also talk about how you calculate the value of a number that goes on for perpetuity purposes, and understand that's just the payment over the interest factor. But that is another way of finding value. So it is included in what we're doing. Housekeeping wise, I still need to go through and change the dates on the homework assignments that are set up in MindTap. I will try and get that done today. It's a matter of me relearning how I set that up so that I can change the due dates. What I'm intending on doing is the chapter 3 due dates for the homework. I'm going to move to, I guess, Monday of next week. Chapter 4, it's going to be Jordan and Casey. You guys have the mini case to do on chapter 4. So be prepared to do that on Tuesday when we come back. We will get started on chapter 5 in my next video, which I'm hoping I'm going to be able to do so that nobody has to show up. Nobody did show up, so I didn't inconvenience anybody. Jordan, I saw you sign in and then you backed out for some reason. But that's fine. I'm planning on posting this video so you can watch it. Please do watch it. I'll send everybody an email pointing out that I posted the video. And then I'm hoping to get another video posted for Thursday, once again, that you can watch at your leisure. Please do make the spreadsheet that we're talking about. And then save it, because we're going to have more functions that we're going to be doing as we get further into chapter 4. Okay. The homework for chapter 5 I will allow to be due probably Tuesday. So chapter 3 and 4 Monday, and chapter 5 on Tuesday. Mini case from Jordan and Casey on chapter 4 on Tuesday. I'm not sure about chapter 5. The mini case is going to probably be, so it'll be May and I think Seth, but I'm not sure if Seth is back, so let me deal with that. we'll talk about that next video. So if you guys have any questions, email me. I will be watching my emails. Probably won't be emailing. Yeah, probably won't email you back in the next 5 minutes after you send me something, but I will. I do check my emails every day, so I will try and get back to you if you have a question. Beyond that, I think we had a good. I felt it was a good lecture on the first part of chapter 4. I don't know how much exposure you guys have had in the past with present values and future values. If you did, I'm sure you didn't have a whole lot of exposure to annuities. We're going to use that, that being able to calculate future value and present value of annuities. An annuity, you think about it, oh, you're going to go buy an annuity from an insurance company, you're going to use that as a retirement. Yeah. But also when we talk about, for example, the thing I talked about, I gave the example at the beginning of class of you spend $100,000 to buy a new machine, and then you have to calculate out, well, what's the, what benefit are we going to get from this machine? So ultimately, you're going to be able to forecast what the increase in profit is going to be over the next, say, 10 years after you buy this machine. What we're going to have to do is we're going to have to bring all of those numbers back as present values. Okay, so you've got this stream of money that's going into the future, and we're going to have to calculate the present value of that. Now, if it's going to be the same amount for X number of periods, then we can use the annuity calculations to figure out the present value of that. But if it's going to be numbers that are all over the place, we're going to end up doing a lot of calculations of specific present values, bring them back to today's dates, add them all together, and then determine, well, the present value of the stream of income is X number of dollars. What did it cost us in today's dollars? Okay. You had to spend $100,000 today money to get these future interests. Okay. We have to figure out what those future monies are valued in today's money so that we can then make a comparison. Okay, we spend $100,000 in today's money, but we're going to get income into the future that when we discount into today's money is, say, $150,000. Do you make that deal? Yes, you do, because you're making $50,000. You're getting a 50% return on your investment, basically in today's money. In future money, it's going to be much larger numbers. But you don't want to spend today money on money that's not going to bring back that much in the future. So if we calculate the present value of that stream of money in the future from buying this machine, and our present value of that future stream of income is, say, $85,000, if we have to spend $100,000 on the machine to get present value of $85,000 in improved income, it's not worth it. So the answer there is no. So these are the tools we're going to use to make decisions in how we run our companies. Okay, being able to calculate present value, being able to calculate future value, being able to understand what an annuity is and how that affects your business is important. Okay, so this is a very important chapter in our decision-making process as we move forward. So if you guys have any questions? Okay, no hands are risen, so I'm going to end this right now. Like I said, take the remaining amount of what would have been class time and put together your spreadsheet. Please do your spreadsheet for those. I can't remember how many I said, 6, 8 formulas that we did. Make sure that you know how to do those formulas. Make your spreadsheet, then save it, because that's going to be useful to you as we move forward in the chapter. You'll end up with a whole bunch of different calculations. And oh, by the way, we will have an exam coming up, and this is the type of stuff that's going to be on the exam. Okay, so understand how to do this. Make sure you know how to use Excel to come up with these financial decisions. All right, that's all I have. This will end up being posted. So today is Tuesday, March 12th, and I will get this posted on Moodle for you guys to look at. When I post it, I will send out an email. So by the time you see this, you'll have already seen the email, so I don't know why I'm telling you. All right, I will let you know whether we're actually going to get together on Tuesday or Thursday, or whether this is going to be a post something similar to this for Thursday. All right, I hope you're having a wonderful week, and I will talk to you later. Bye.